Hi, I'm Jared.
I'm Jason. And I'm Benito.
This tutorial will show you how to assemble and program a traffic light. You will need blocks to mount your lights onto, 1 switch, 3 light bulbs, and 3 different colored light covers, 1 red, 1 amber, and 1 green. To assemble the traffic light, use 2 30mm blocks to mount the lights onto. Mount the light onto the blocks in this order: green light on the bottom, amber in the middle, and red on top. To wire the traffic light, you will need at least 15 wires and one 10K resistor. Use 2 of the wires to connect the 5V to the positive on the breadboard and the G and D to the negative. To wire the switch, connect 2 on the switch to the negative on the breadboard and 1 on the switch to a row on the breadboard. In the same row, add a resistor and another wire, which is to be connected to DIO0. Using another wire, connect the wire in the same row as the back end of the resistor to the positive on the breadboard. That's how you wire the switch. To wire the 3 traffic lights, connect the light bulbs to the outputs. Connect the red light bulb to output 1, the amber light bulb to output 2, and the green light bulb to output 3. Then use wires to connect DIO1 to EN1, DIO2 to EN2, DIO3 to EN3. That's how you wire the lights. Next is programming the traffic lights. First, create a while loop to encase the program in. Next, create a stop button and connect it to the loop condition in the while loop. Inside the while loop, add a case structure and connect the case structure to the loop condition. In the true case, you are going to need a DAQ assistant. Go into Express to Output to DAQ assistant. Then click into Generate Signals, then into Digital Output, and into Line Output. For the green light, click onto Port 0, Line 3. Test the DAQ assistant, and when finished, click OK and rename the DAQ assistant to green so that you don't forget it. With the green DAQ assistant done, add a build array and a true boolean connecting the true boolean to the build array to the green DAQ assistant. In the false case, add another case structure. In the case structure you just made, create an enum. To create an enum, go to numeric to enum constant. Right-click the enum and click Edit Items. In the properties of the enum, insert 4 values: green as value 0, weight as value 1, yellow as value 2, and red as value 3. With the enum finished, add a case for every value that was created, meaning you will need 4 cases: a green case, a weight case, a yellow case, and a red case. Copy and paste the enum and put it in every case while also wiring it to the right wall of the case structure. Set the enum in each case to the function it will run next: weight enum in gray case, yellow enum in weight case, red enum in yellow case, and green enum in red case. Using the tunnel created by wiring the enum to the case wall, wire the enum to the case selector. While wiring the enum to the case selector, a feedback node would have been created. If not, add a feedback node. Copy and paste the enum and wire it to the feedback node, and set the enum to the function it is going to do first. In this case, set the enum to green. Next is the programming in each of the cases. Starting with the green case, create a while loop inside of it. Using the DAQ assistant, go to Express to Input to DAQ assistant. In the DAQ assistant, click on Acquire Signals to Digital Input to Line Input. Select Port 0, Line 0 for the button and make sure the button works properly before clicking OK. Create an index array and a constant with the value of 0. Wire the DAQ assistant to the top of the index array and the 0 constant to the bottom of the index array. Wire the index array to the loop condition. The button is finished for programming, and now we need to program the lights in each case. Still in the green case, create two DAQ assistants, one for the green light, one for the red. You can copy and paste the green light from the true case, but creating the red light is similar. Click on Express to output to DAQ assistant. In the DAQ assistant, click Generate Signals to digital output to line output. For the red light, however, connect it to port 0, line 1, and click OK if it works properly. Create a true boolean and a false boolean and add two build arrays, one for each light. Wire the true boolean to the build array to the green DAQ assistant and the false boolean to the other build array to the red DAQ assistant. Next is the wait case. To simulate the wait time for the button to the amber light, add a timer by going into timing to wait milliseconds. Set a constant for the wait to 10,000, which is 10 seconds. Copy and paste the green DAQ assistant and add a true boolean and a build array. Wire the true boolean to the build array to the green DAQ assistant. Next is a yellow case. Add a wait timer with a constant of 5,000, which is 5 seconds, to simulate the amber light delay. Copy and paste the green DAQ assistant, but create a DAQ assistant for the yellow light. It's the same as the other two light DAQ assistants. Express to output to DAQ assistant. Then in the DAQ assistant, generate signals to digital output to line output, but this time connected to port 0, line 2. Now that the yellow DAQ assistant is done, add a false and true boolean and two build arrays. Wire the true boolean to the build array to the yellow DAQ assistant and the false boolean to the other build array to the green DAQ assistant. Last case is the red case. To simulate the time the red light stays for, add a wait timer with a constant of 30,000, which is 30 seconds. Copy and paste the red DAQ assistant and add a yellow DAQ assistant. Add a true, a false boolean, and two build arrays. Wire the true boolean to a build array to the red DAQ assistant. Wire the false boolean to the other build array to the yellow DAQ assistant. And that's the end.
Oh shit. Can I hear the